Hello viewers, welcome back to our channel, and today we are going to solve again systems of homogeneous differential equations, but today we are solving non-homogeneous systems. And remember, in the previous videos we were just solving homogeneous systems using matrix method. Today we shall solve non-homogeneous systems. We say a non-homogeneous system of a linear differential equation takes on the form x prime equals to ax plus f at t, and we shall always use the method of undetermined coefficients and the method of variation of parameters to solve these systems. And today we shall talk about how to solve the method of solving using method of undetermined coefficients. When you are solving non-homogeneous systems using method of undetermined coefficients, we have 3 steps to follow. The first step is for us to solve the homogeneous part, x prime equals to ax, to obtain the complementary solution at x c at t. This one is what we have been doing in the previous videos, and then we assume the partial solution for this f at t, which we don't know, and then we solve for it, and then lastly we find the general solution by adding x at the complementary solution plus the partial solution at t. Now today, allow me to take you through on how we assume the particular solution, and then we do an example on how we solve a system using method of intermediate coefficients. Now if I put off this first, if I put off this, remember from our previous videos, we said that we shall always assume our tripartite solution by according to what we have in the question. Now just take an example. If my f at t is something like 1 and 2, what will be my tripartite solution? Remember in the previous video, in chapter 3, we saw that if I had something like my x at p, to say my solution here was something like a linear equation like 1, we could let our xp to be something like a. If we had something like a 2, that's a constant, we said let it be a or any constant b. Remember, if we had something like our f of x as to say it is now like 2x, we could say let our xp to be, we could say let it be ax plus b. But I think you got these things we used to do in our previous videos. Also here, we assume that our f of t at that point is just a constant a. Therefore, my xp, I want my xp to be just it's going to be a constant again. I'll have our a here, a1, and then a b here. Just like that, as simple as that. Now take another example when you are given our f of t. Now if my f of t equals to t, and then here a 4. Now from here, allow me to first split this one to see correctly what to let and what not let. This is the same thing as having because if I take of t, here I have 1t and then 0t, like this is the components of t, and then plus, now here I have something like 0 and then a 4 here. This much is the same as having this one here, because I'm just letting for t, I have only 1t here, then I have a 0t down here. Then for composite, I have a 0, I have a 4 here, and then I'll have a 0 up here. Now for this kind, we shall let our, since I have a constant here, I'll say this is going to be my x at p. I'm saying my xp. I have a constant here. I'll have a1, then I'll have b1, everything at t. Now plus, now here I'll have a2. Since these are also constants, then b2. And therefore, my x at p, what I will let is going to be the same as having a1 t plus a2. If I open brackets, then I have b1 t plus b2. I think that you are getting me. Now another example. Take a case that I have something like if my f over at t is me having like e power t, and then I have the t down here. The first thing you have to do first split that thing to have, in terms of e power t, you have In terms of e power t, I have 1 here, then I have a 0. Here, e power t. Then in terms of t, I have plus 0, I have a 1. Then here I have the t this side here. Now remember last time when we were letting our f, if my f of x, I have something like e power t. We used to say that let our xp equal to a e power t. Therefore, I'll write something like a here. Therefore, I have something like inside here I have a1, then b1, because this have to be the same thing. Then e power t, and then plus. Now also here I have, now since I have a1 and I have here a2, and then here I have b2 t like that. And then finally my particular solution xp is going to be the same as having a1 et plus a2 t that way out of, then here I have b1 et and then plus b2 t. I think we have been on those steps. It will vary according to what you have been given. Now what you have to know is you to know how to let a write xp solution. Lastly, let us do this example. Then we are given something like, maybe given something like our f at t. Now I'm given f at t. My f at t is going to be the same as t e power t, and then I have a 2 here. Now what I have to do, I have to split. I'll have something like t, then I'll have a 0 here, then e power t, then plus 0, and then a 2 as for constants. For e power t, I have t, and then I have a 0 here, and then for constants, I have 0 and then a 0 here. Now remember now here, if I have a t here, what do I do? So say if my f of x was equal to x alone, I could say it's the same. My xp could be my ax. I could let my ax plus b. Therefore, also here I have to let something like my x here going to be a1 t plus a2. Then also then I have to have the same thing, b1 t plus b2. The whole of this is under e power t, then plus here I have a3, then b3, because these are constants, and therefore I will be able to write that my xp, this is my xp. I have my xp the same as having a1 t a2. This thing is equal to e power t, now plus a3, now b1 plus, sorry, b1 t, there is a plus b2 e power t plus b3, right? That format. I think we shall be able to do more with experience. If you have experience, you'll be able to get to know what to do here. Now let us solve a system, one homo system, using method of undetermined coefficients to see how we can go about it. Yes, let me put off this. We are solving now. We find the question. They say use question 1. They say use the method of undetermined coefficients. Undetermined coefficients to solve. My system is this way. I have a system in this format. It is dx, it is dx dt equals to 3x plus 3y plus e power t, and then dy dt equals to negative x minus y plus e power 3t. Yes, this is our system. The first thing we have to do, we have to first make our system to be the format x prime equals to ax plus f at t. This is the first step we have to do. Now for me, from here, I said my x prime equals to my a. I wrote the coefficients of x and y. I have 3, and I have a 3 here. I have negative 1, then negative 1 here into x, because this capital X is representing x and y. Then f of t plus f of t, those should be the same as having e power t and then 3, e power 3t. This way. And then this is what will be our equation. This system is reduced into this equation. Therefore, we can easily solve this equation now. As we say that, when we are using method of undetermined coefficients, we use 3 steps. The first step is for us, we said, we call that the first steps we use. The first step is for us to solve this homo system, x prime equals to ax, like that, for us to get the preparatory solution, to get xc at t. Then step 2, we assume xp, we assume the partial solution at p at t. Then we solve for this one, you get the answer also. And then the last step, we find the general solution, x at t, the same as having x at c at t, then plus xp at t. Now, let us go step by step so as we get the solutions now. My first solution is for me to solve the homo system. Then, for solving the homo system, it is simple because I've been doing it. I put off these steps, I get space now. My step is finding the homo system. How do I solve the homo system? I'm solving now the homo system. I'm solving something like x prime equals to a. My a is now 3, negative 1, 3, negative 1, now x here. When we are solving a homo system like this, we solve it using eigenvalues and eigenvectors. Now my first step here is to find the eigenvectors. I first find the eigenvalues. Step 1, I find the eigenvalues from our equation at a minus lambda I equals to 0. But remember, my a minus lambda I equation is going to be the same as having, remember my a is 3, negative 3, 3, negative 1, negative 1. And if I put there minus lambda, I will have 3 minus lambda, then I have a 3 here, then I have negative 1 minus lambda. Like that. Then, for me to find the eigenvalues, I just have to define the determinant of this matrix here. Then I have now 3 minus lambda into negative 1 minus lambda, like this. Now, I said row, I multiply the major row minus the minor row, minus, then plus now 3 equals to 0. Then I will have something like 3 times negative 1, I have negative 3. Now 3 times negative lambda, I have negative 3 lambda. Then negative lambda times 1, I have plus lambda. Then plus lambda squared plus 3 equals to 0. Now from here, I'm seeing that this is plus, plus 3, yes. Now from here, I'm seeing that this 3 goes with this 3. Then I will remain with lambda squared. Now minus 2 lambda equals to 0, and then my lambda 1 equals to 0, and then my lambda 2 equals to 2. Therefore, I have got my eigenvalues, lambda 1 and lambda 2. Second step is for me to find the corresponding eigenvectors. So eigenvectors for lambda 1 and lambda 2, respectively. Now what I have to do here is just find the eigenvalues. So eigenvectors for the corresponding eigenvalues. So for lambda 1 equals to 0, what will be our eigenvalue is our first solve the system 1 minus lambda I equals to u equals to 0. Now if I put in my lambda is 0, I'm putting 0 here everywhere where the sign I put there is 0. Therefore my system here is going to be the same as having 3, then 3, negative 1 times u equals to 0. This is the same thing as having 3, 0, 0, and then I have negative 1 in something which is implemented like that. Then if I reduce to echelon form, I'll have the first row as 3, then 3, 0. Then if I reduce to echelon form here, I'll add. I'll say 3 row 2, minus root 3, I get a 0 here. Then I also get a 0 here, then a 0 here, using row echelon form. Now, my u2 is a free variable. I just say let my u2 equal to r. Therefore, my 3u1 plus 3r equals to 0, and therefore my u1 equals to negative r. Therefore, I'll be able to write my u1, u2 equals to negative 1, 1, r. Then when r is 1, my u equals to negative 1, and then a 1 here. Therefore, I'll be able to write my first solution, x1 at t, the same as having negative 1, 1, then e power lambda t, but my lambda is 0. There I have e power 0, which is 1. Therefore, I have this one going to be there. Now from there, I find the corresponding eigenvalue value for, I find the corresponding eigenvector vector when lambda is 2. So now when lambda is 2, what will be my eigenvalue? A minus lambda I, then v equals to 0. Then if I put where there is lambda, I put there 2. What do I have as my matrix? I have 3 minus 2, which is 1. Then what is here? I have a 3. Then here I have negative 1. Here I have negative 1 minus 2. I have negative 3 times v equals to 0. This is the same thing as having times v equals to 0. The same thing as having 1, negative 1, 3, negative 3, then 0, 0. Then I reduce it to a clone form. I'll have 1, 3, 0, and then I'll have 1 plus row 2, I'll have 0, 0, and a 0 here. Now, if I set my v2 to be a free variable, I said my v2 equals to r, therefore v1 plus 3r equals to 0, and then for my v1 equals to negative 3r, and therefore I'll be able to write that if I put off this h space. Yes, I think we shall recall our now my f at t. Remember, I need f at t. I need it is e power t, then e power 3t. I need this f at t because I have to use it in assuming our particular solution. Now from there we can easily put off this and then we see what to do. Now from that step we've got our v1 and v2. If my v1, then v2, this one is negative 3, v1 is negative 3r, and then v1 is 1 in terms of r. Then when r is 1, therefore my v equals to negative 3 and then a 1 this side here, in that form. I think we are still together on that step there. Therefore, my second solution is going to be my x2 at t, the same as having v, which is negative 3, 1. Now, e power, my lambda is going to be 2, and then t. Therefore, my x at c, my convenient solution c equals to c1 plus c1x1 plus c2x2. There c1x1 is c1 negative 3, 1. Sorry, c1x1, x1 is this one we got here. c1x1 is negative 1, 1. Then plus c2x2. What is x2? x2 is this one, negative 3, 1, e power 2t as my x at c. Now we need to find now x at p. We just got only x at c. Now my task here is finding now x at p. How do you find x at p now? Remember my f at t. Remember my f at t equals to e power t, then e power 3t. E power t, yes, and e power 3t. Now this is the same thing as having, if I expand it, in terms of e power t, I have only 1 here and I have a 0 here. Of e power t, like this. Now plus, for e power 3t, I have a 0 here, I have a 1. E power 3t. But remember, if my f of x is e power t, My solution is going to be a e power t. Therefore, just let my a to be here. Then I have something like the same thing as having a1 b1 e power t, then plus also the same thing here. I have now a2 b2 e power 3 t, and therefore my x at p the same as having, if I add them, I have a1 e power t plus a2 e power 3t, like that. They're together like this, and b1 e power t, b1 e power t, then plus b2 e power 3t. This is going to be my x at p. Now, since we have our differential equation in this format, remember our equation was like this. I think we just need this. I've been speed because we have been doing the part we have been doing always. Now here I want to go slow. Remember our differential system. Our system, we reduced it into this equation equals to ax plus f at t. Now I have got my x at p. Now what I need is to differentiate this one the first time. Then if I differentiate the first time, then I have to fit into this equation we have there. Now if I get the first derivative at this one, f x at p, the first derivative, let's differentiate this one here. I have, if I differentiate this first term here, I have a1 e power t. If I differentiate e power t, I'm going to with e power t. If I differentiate down here, I have 3 a2 e power 3t plus 3 a2 e power 3t. Now down here I have b1 e power t, then plus, now I have 3 b2 e power 3t as my xp at t. Now since I need this big space now, allow me, you first write somewhere this solution because I will need it, and then allow me put off everything here so as to have a big space and we do the remaining work together. I don't know how to leave anyone behind. Now if I put off this solution here, if I put off this, and then I feed them back into this equation. Remember, I'm feeding back into this equation. So we had our x at p. Our x at p was originally like this. And then plus a2 e power 3 2, then b1 e power t plus b2 e power 3t. This is my xp I had originally, and then this is my xp prime. Then I want to feed this one into this equation which we had at the start. Now for me to feed in, I will just say that xp, the first derivative I have, this is the same as having e a1 e power t plus 3 a2 e power 3t, like this. Now b1 e power t plus 3 b2 e power 3t. This is my derivative. Now plus what equals to, what is my a? My a was originally 3. My a from the equation we had, my a was 3 negative 1 negative 1, and then my x now is what? Is this equation here we have. This is my x. I have a1 e power t plus a2 e power 3t, and then I have b1 e power t plus b2 e power 3t, like that. But plus f of t. F of t we had it already. And plus f of t plus f of t. My f of t was e power t and then e power 3t. Now I think for us, we are together. Now I want to compare coefficients, but I need first to make this side one thing. Now for me making that side one thing, I'm going to just do like this. If I multiply row by column, this one times this one plus this one times this one. Yes, I'm going to make row by column. I have this one times the, like that. I make a row by column. Then this is the same thing as having 3 into a1 e power t plus a2 e power 3t. Now plus 3 into this column, row by column. Yes, into b1 e power t plus b2 e power 3t. But now plus this e power t, which is there. Now here, the other thing I have negative 1 times this one, have negative 1 into a1 e power t plus a2 e power 3t, like that. Now minus 1 into again b1 e power t plus b2 e power 3t plus e power 3t, like that. And then this is just our general matrix, which I'm comparing it with this matrix here, which is here I have a1 e power t plus 3a2 e power 3t, then here I have b1 e power t plus 3 b2 e power 3t. Now from this step here, what you have to do, I just want to compare coefficients now. I said from here I said comparing coefficients. Comparing coefficients. Remember, we are still finding for xp. The only steps have been I want to find xp. I want to get the value of a, the value of a2, the value of b, the value of b2. That way. Now, for compare coefficients of all values with e power t. If I want to see e power t, both sides, here and other side. Now, for e power t here, I'll have, what do I have here? I'll have e power t, I have a, here I have a1, so I have only a1, which has e power t. Then inside I'll have what? We have e power t, I have equals to 3a1, here I have 3, then a1, then here I have plus 3b, b1, because it has a1 e power t, and then plus 1. That's the first equation. Eh? Now also upwards, here I will still compare for e power 3t. If I look at this first row again, I have here I have 3a2, here I have 3a2, here is the component of 3 e power 3t, the same as having equal to, this side I have 3 and then this one, 3a2, like this, then plus, here I have 3, here I have 3 and then this b2, plus 3b2, like this. But now from here, I'm saying that these ones are the same. I just cancel out. I'm going to b2 equal to 0. Now from here, I just say that b2 equals to 0. I've got one value. Remember, I'm looking for a1, a2, a1, a2, b1, b2. And I've got one value from just this equation. When I'm seeing this one, going to this one, I'm going to be b2 equals to 0, then b2 is 0. Now, if I compare now the down part here, I have something like, for e power t. What will I have down here? For e power t down here, I have b1. This is the b1 I will have here. I have b1. I will have b1 e power t. Then instead I will have negative a1 equals negative. I have b1 here, negative a1. Then here, negative a1 and a negative, I think b1, negative b1, like here, like that. Is it? I have b1. Yes, I think it's that. I have b1 this side as a coefficient of e power t, b1. Then inside I have here only a1, which is negative. Then here I have, yes, a1 which is negative. Then here I have negative b1 which is negative also, like this. Therefore from here, I can just say that a1 equals to, if I put this on the same as having a1 equals to what? Negative, yes, negative 2b1, like that. If I put them, if I write it like that, because I'll take this one, this side here, this one comes negative. Yes, the same as having this one. This is also important to consider. Now from that step again, we shall just say that now comparing coefficients of e power 3t. What I have this side? I have 3b2, like that, equals to what? What do I have this side? I have negative a2, then minus b2, minus b2 here, then plus 1. But remember, we say that b2 is 0. Then if I have b2, if I have 0 here and 0 here, therefore my a2 is 1. My a2 is what? Is 1, yes. My a2 from here, if this is 0 and this is 0, therefore my a2 is 1. Therefore if my a2 is 1, therefore I find b, I find I can find my, if my, I'm saying that my A2 is 1. Now I can easily now solve these two equations here for me to get my A1 and B1. Then by replacing here, if I replace where there is A1 with negative 2B, what do I get? I have negative 2B. I'm saying replacing, just replacing here. I have, where there is A1, I put a negative 2B. Negative 2B1 equals to 3 into, this is going to be negative 6B1 plus. I'm saying that if you compare these two equations, this one and then this one here, so I'm able to get my value of A1 and B1. Then if I just replace here where there is A1 with negative 2B1, I have negative 2B1 like this, as here as A equals to now negative of negative 6A1 plus, sorry, B1, it's not A1, B1, then plus 3B1, then plus 1. Then if I put the B1 together, I'll have this, if you come this side, I'll have negative 2 plus 6, so it will be 4, and then minus 3, which is B1. Therefore, my B1 equals to 1. I have B1. Therefore, I'll be able to find my A2. Therefore, my A2 the same as having negative 2 B1, which is negative 2. Therefore, my B1 is 1. My A2 is negative 2. We said my A2 is 1, and then my B2 is 0. Therefore, I'll be able to write my xp in a more simplified form with A1, B1, and B2. Then I'll have now my, remember my x at p. My xp is was what? I think you recall it was, you said that let it be something. My x at p, we say that it is A1 e power t plus A2 e power 3t, like this, out of B1 e power t plus A2 e power 3t. This is our xp. Now I've got different values of A1, A2, A3, and A4. This is A2. So A2 is 1, not negative 2. So this is A2. This is A1. So I'm saying A1. This is A1. A1 is negative 2. Yes, negative 2. A1 is negative 2. Then A2 is 1. Then if I place them back into this equation here, I'll be able to get my x at p. Now, I think I've been following. Let me put off this, then I write my x as it is. Then if I put off this here, now my xp, I'm saying that xp is the same as having, now what is my A1? My A1 is 1, then I have e power t. Then what is my A2? My A1 is negative 2. My A1 is negative 2 e power t. And then what is my A2? My A2 is 1, then plus e power 3t. And what is my B1? B1 is 1, I have e power t, then plus A2. So this is not A2, this one is B2. Here I have, we said this is B2, not A2, it is B2. My B2 is 0, then I have 0 there. 0 plus 0. Therefore, this is going to be my x at p. I think I've been following the steps I've been doing. Now, from this step, now we can easily write our final general solution. Therefore, my general solution is going to be the same as having x at t, the same as having x at c plus x at p into t. And then you saw that our x at c, we already had it. X at t, the same as having x at c, we had it already. It was c1. It was c1 into x1 at t, which was c1 was c1 into negative 1, then e power 0, then plus c2, which was negative 3, then 1, e power 2t, now plus x at p, plus x at p, which is this one. negative 2e power t plus e power 3t, then e power t as my solution. Then this will be my complementary, this will be my general solution for that unhomogeneous systems of equations. I think we have been together and you have enjoyed these calculations. Thank you for following. Just wait for more videos in this format.